is we are going to create our own series circuit and analyze it completely. So I should have page 4 out on my reference table, and feel free at various points throughout this video to pause it and try some of these calculations on your own to make sure that we are all on the same page. So first thing, what we want to do is we want to draw this circuit. So I should be looking at the symbols. If I look at the symbol for a battery, I'll start here. And I'm going to put 3 resistors in my circuit. But I also want to be able to measure the voltage across a resistor and the current in the circuit. So in order to measure the current in the circuit, I want to place my ammeter as close as I can to the battery. That way we know that all of the current is going through the ammeter. And we always measure the potential difference across the resistor. So that would look like that. I could do this for any of them. And in order to analyze this, I have to pick random numbers. So let's say that I want my battery to have a voltage of 120 volts. Let's say my first resistor is 40 ohms, my next resistor is 50 ohms, and my third resistor is 60 ohms. Now, in order to analyze this completely, I want to find the REQ. I want to find the current and the voltage across each resistor. And then later on, I'm probably going to find electrical power and electrical energy through one of the resistors. Okay, so the first thing that I want to do is I want to find the total resistance. So the first thing, always write our formula for total resistance. R1 plus R2 plus R3. And now we just simply plug in our values. So our equivalent resistance is 150 ohms. Now this is important because I cannot find the current until I have the equivalent resistance for a series circuit. So now to get the total current in the circuit, I'm going to use Ohm's law, and I'm going to use R, and it's going to be the equivalent resistance equals the voltage. Oops, didn't mean to change color. Over the current. So R equals V over I, Ohm's law. Now we can plug in. I have a total resistance of equivalent resistance of 150 ohms, 120 volt battery, which gives me the current of 0.8 amps. So that's good. So this ammeter would read 0.8 amps. And since this is a series circuit, there's only one path for current to flow. So if we place an ammeter here, it would also read 0.8 amps. And if we placed it here, same thing. It would read 0.8 amps. The next thing for me to analyze is the voltage drop across each resistor. And what this multiple choice question could ask you is, what is the reading in the voltmeter? And the way we would analyze that is, again, we're going to use Ohm's law, which is R equals V over I. We know the resistance here is 60 ohms. We know that the voltage here, it's not 120. It is what we're looking for, so we're going to leave that as a variable. And the current here, no matter where, anywhere in this circuit is 0.8 amps. So multiply that out, and we should get a voltage of 48 volts in this voltmeter. So this would measure 48 volts. And now I can do this for each resistor. If I want to do the next one, 50 ohms equals what we're looking for. So if this was another voltmeter, so voltage here would be 40 volts. And lastly, we have a 40 ohm resistor looking for the voltage, and the current is 0.8 amps. Which is 32. Now, if we did this correctly, when we add up, gotta put my units, when we add up 32, 40, and 48, we should get 120 volts, and we know that we did it correctly because it matches the total voltage of my battery. And the last thing that I want us to find is, let's focus on one resistor. So let's focus on the 60 ohm resistor. Now what I want to do is I want to find the power dissipated by this resistor. So we can use any one of these formulas on the reference table. It doesn't matter which one we use because we have the information to fill out all these, but I'm just going to use the first one for now. The voltage at this resistor is 48 volts. The current, I know it's series, so it's everywhere, is 0.8 amps. And we should get a power of 38.4 watts. And then if I wanted to know the electrical energy that this resistor uses in, let's say, 1 minute, the electrical energy is equal to power times time, where we just found the power. And I said 1 minute, so 60 seconds. And this would use 2,304 joules of energy in 1 minute. Analyze a parallel circuit, and I'm going to use the same numbers that I used in the previous one, just so we can compare the current and the equivalent resistance, and really see how things change based on how they're constructed. Excuse me. So again, I'll start with my battery. Oops. And now with the resistors in parallel, current's going to split. So it might look something like this. Now, I said that R1 is 40 ohms, 50, and 60 ohms. So these are going to be the values of my resistor, and we'll keep it as a 120 volt battery. Now, the nice thing about a parallel circuit is I don't have to measure the voltage anywhere, because no matter where I am, if my battery has a voltage of 120 volts, at resistor 1, it's 120 volts, at resistor 2, it's 120 volts, and at resistor 3, it's 120 volts. So no matter where we are, the voltage will be the same. And this is very helpful when we're considering the brightness of light bulbs and things of that sort. So now if I want to find the REQ, I have to use my parallel rules. 1 over R1 plus 1 over R2 plus 1 over R3. So we have 40, 50 ohms, and a 60 ohm resistor. Let me do this in my calculator very quickly. So we get the REQ of this circuit to equal 16.2 ohms. And if you are having trouble getting this, make sure you reach out to me and I will show you a nice trick on how to do that in your calculator very easily. So now that we have the equivalent resistance, let me write that up here. You can see this is a lot lower than the series circuit. So by constructing resistors in parallel, the resistance goes way down, which means the current is going to go up. And to solve for current, I'm going to use Ohm's law. We're going to use REQ, so we're going to have 16.2 ohms equals the voltage, 120 volts, over I. We're going to get the current in this circuit to equal 7.4 amps, which is a lot higher. Okay, so now that we have the total current in the circuit, what that would mean is that if we place an ammeter right here, this ammeter would read 7.4 amps. But as current leaves the battery, some of it's going to go this way, and some of it is going to split. So if we placed an ammeter right here, let's call this A1, call this A2, and A3. All of these are going to have different values of current. And the way we would calculate these is, yep, you guessed it, Ohm's law. So let's look at this one first. Start with Ohm's law. Now I'm looking for the current in each one. I know the resistor here is 40 ohms. I know the voltage is 120 volts because in a parallel circuit, the voltage is the same everywhere. And here I'm looking for current. So I get the current, or in I1 or A1, to be 3 amps of current. And you'll notice the higher the resistor is, the less current there should be, because with higher resistance, less current can flow. So let me go on to the next one. Talk about R2. That's the 50 ohm resistor. Yep, the voltage is still 120 volts. And the current, cross multiply, divide, 2.4 amps of current in this second one. And then we'll do the third one quickly. Say the third. This is the 60 ohm resistor, still 120 volts. And we're looking for the current. So through the third resistor, there should be 2 amps of current. And now to double check my work, I know that there should be a total of 7.4 amps. So I'm going to add up the 3 different currents which split 3 amps plus 2.4 amps plus 2 amps. Plug that into my calculator really quick, or if I could do some mental math, that would be great. Yep, 7.4 amps of current, therefore it matches, and I am good to go.